Let us see what a neural network is with a simple example. A neural network, like any machine learning model, makes predictions based on inputs. But don't worry about the technical details. Instead, let's focus on a simple example. By the end, you'll have a much clearer understanding of what a neural network really is. Let's imagine a neural network that predicts whether John will decide to watch a movie based on four factors. Is it a comedy film? Is it a weekend? Is it evening? Are friends coming along? John values some factors more than others. Friends coming along is very important, so it gets a weight of 4. Weekend is somewhat important, so it gets a weight of 2. The type of movie and time of day are assigned a weight of 1. These weights are based on historical data, but can change over time as more data is gathered. Now, let's predict if John will watch a comedy movie on a weekday evening when friends are coming along. Here's what we know. Is it a comedy film? Yes. Is it a weekend? No. Is it evening? Yes. Are friends coming along? Yes. We calculate the output by multiplying the scores by weights and summing them up. So, the output value is 1 plus 0 plus 1 plus 4 equals 6. Now, assume John needs a score of at least 5 to decide to watch the movie. At this point, the raw output value of 6 will be passed through what is called an activation function. The activation function helps make the final decision. In this case, let's use a simple threshold-based activation function. If the raw output value is greater than or equal to 5, the activation function will give an output of 1, meaning John will watch the movie. If the raw output value is less than 5, the activation function will give an output of 0, which means John will not watch the movie. In our example, since the raw output is 6, which is greater than 5, the activation function's output will be 1. So, our neural network predicts that John will most likely watch the movie. If John actually watches the movie, the weights or priorities stay the same. But if he doesn't watch it, the system will adjust the weights to better reflect his preferences for future decisions. In short, the process has 4 steps. The model takes in several input factors. The model assigns importance or weights to each factor based on past data. The model calculates an output. The model readjusts the weights based on feedback to improve future predictions. I hope you now have a better understanding of a simple neural network. The network we discussed in the example had a single layer. A layer in a neural network refers to a set of inputs or neurons that process information and lead to an output. Our example represents a single-layer network often called a perceptron. In complex networks, there are multiple layers, each performing calculations and passing their results through activation functions. These layers work together, interacting and refining the raw outputs to give a final decision or prediction. This allows neural networks to handle more intricate and nonlinear relationships between inputs.